Hello everyone. We will see the type of rectifier. That is, we know that there are two type of rectifiers. That is, one is half wave rectifier and second one is full wave rectifier. Again, full wave rectifier has a two types. One is your center tap full wave rectifier, and second one is bridge type of full wave rectifier. So we will see this bridge full wave rectifier in this lecture. So in this type of rectifier, this rectifier is designed to overcome all the disadvantages which is caused by the center tap full wave rectifier circuit. So in this case, four diodes, diode D1, D2, D3 and D4 are used. They constitute the bridge type of network. That's why this type of rectifier is called as full wave bridge rectifier. So if we see this diagram, there is a input AC input voltage that is given to the transformer. Then from the secondary of transformer, it is given to the bridge network, and the output is taken across this load resistors. So we will see the working of full wave bridge rectifier. So next, in this diagram you can see the working of full wave bridge rectifier for the positive half cycle. So if you can see that this AC input is applied, then during this positive half cycle of AC input, this point P of secondary of transformer, it will become positive with respect to point Q. That means the P is become positive and Q is become negative. So due to this positive power supply is connected to the anode of the diode D1 and also to the anode of the diode D3. That's why this diode D1 and D3 this will make the diode D1 and D3 in forward bias, and diode D2 and D4 will become reverse bias. That's why there is a output for the positive half cycle for the AC input of positive half cycle. So you will get the output across this load resistor for the positive half cycle. So you can see that these are the waveforms. This is the input waveform. You can see this is the AC input waveform, and there is on the left side, that is the output for the positive half cycle. So during the positive half cycle of this AC input, you will get the same output at the output side as that of input. That is, during this positive half cycle, diode D1 and D3 as will conduct, and during this D2 and D4 are in off condition, so that you can get only output for the positive half cycle. So for the negative half cycle, for the negative half cycle of the AC input, we will see this diagram again. So during the negative half cycle of the AC input, this point P will become negative with respect to point Q, and this will make the diode D1 and D3 in the reverse bias, and this will make the diode D2 and D4 in the forward bias. So that diode D2 and D4 will conduct during the negative half cycle, while D1 and D3 are in off condition. So there is a output because of diode D2 and D4 during the negative half cycle. So, and in this arrow indicate the direction of flow of conventional current in the circuit. So we know that during negative half cycle, diode D2 and D4 are in forward bias, and there is a current flow through the load resistance, and that will appear at the output. So output for the negative half cycle, you can see that for the this is the AC input waveform, and for the negative half cycle you can get the output same as that of for the positive half cycle, but during that negative half cycle you can get output due to the diode D2 and D4. In this case diode D1 and D3 are in reverse bias or in off condition. That's why there is a output during the negative half cycle is due to diode D2 and D4. So in the last waveform of the right hand side you can see that the output, that is the total output during the positive half cycle as well as the negative half cycle, you can get the output. So there is a no loss of negative half cycles in this bridge wave rectifier. So you can get the output as shown in this waveform. So last, these are some advantages of the full wave bridge rectifier. There are many advantages. There are many advantages of the full wave bridge rectifier. They are such as there is no need of center tapping, as we know that in case of center tap full wave rectifier there is a center tap transformer is required. In this case of full wave bridge rectifier there is no center tap transformer is used. That's why there is no need of center tapping. The DC output voltage is twice that of the center tap full wave rectifier. The output the DC value of the output voltage of this of the bridge wave rectifier is also twice. Then PIV of the diode is reduced to half, and its design is also very easy in case of full wave bridge rectifier. So this is all about the full wave bridge rectifier. Thank you.